So these are questions from our 4.7 assignment. We're going to look at number 9, which was the inverse sine of negative 1 over root 2. Does it bother you guys that they didn't rationalize this? I've been harping on you forever that you got to rationalize your denominators. If I put something like this on the test and I don't rationalize it, the reason I'm doing that is not to be two-faced about the whole thing, but it's because it'll make it easier for you to spot the triangle. So they could have, a more difficult version of this would have been for them to say, find the inverse sine of negative root 2 over 2, which is the same thing. But this way is a little bit easier because it's going to, the numbers that you put on your reference triangle will be more familiar to you. So, all right, so what do I need to remember? I need to remember the inverse sine has a limited range. It can only give me answers in, sorry, not that one. Yes, that one and this one, those two quadrants. Inverse sine is only going to give me answers between negative pi over 2 and positive pi over 2. So I need to draw my reference triangle on one of those. The fact that the inverse sine is negative tells me that I need to draw it in this one. Of those two quadrants, that's where sine is negative. So this is my ratio. Sine is opposite over hypotenuse. And then we recognize that that is a 1, 1, root 2. That's a 45, 45, 90 triangle. So my answer in degrees would be, it would need to be negative 45 because it's going down. So negative 45 degrees, but they're probably going to want radians. I'll ask for radians on the test. So that's negative pi over 4. And I think I just gave you the wrong answer. I must have been looking at the wrong section. So, okay. So negative pi over 4. And again, if you were doing this on a test and you had some extra time, make sure, I'm going to make sure that my calculator is in radian mode. And I can just type in the inverse sine of negative 1 over root 2. And then type in negative pi over 4, and that makes me feel pretty good. All right, anything else from that? On your test, you're going to have one problem that it'll just be a single sine, like inverse sine, inverse cosine, or inverse tangent. By the way, I'm not going to throw any inverse secants or cosecants. It doesn't look like that was on your practice set either. But there'll be one where it's just a single inverse sine, cosine, or tangent, and there'll be one where it is an inverse nested inside of a regular or vice versa. So kind of like 23 to 31. We did some of those problems, didn't we? Probably not like 27 with that 2 there, but were there any others that you guys would like to go over from here? 23, 25, 29, 31 would be the best choices. You guys all did those problems and you're confident you got the right answers. Okay. All right, well, we'll skip those 2 and we're going over our little practice test since we've done those. Any other questions from 4.7? How about from the review? Let me grab a copy of that. I know you guys have been working on that. It will be due on Friday, or not Friday, Wednesday. Answers are posted on Canvas. All these problems, well, many of these problems were chosen because there is a problem very similar on the test, but there's some stuff on here that's not on the test, but that could be on the final exam, in particular the CWU exam. So not everything here is something you're going to see on the test, and the order is not the same. But I'd be happy to go over any of them. Yes? 11A, yeah, let's have a look at 11A. Thank you for asking. Great. There will be two problems similar to this on the test, so we'll do this one, and then I'll give you one more that we can practice as we do our little practice test today. All right, so we need to make a reference triangle, but we got to get it in the correct quadrant. So the first order of business is to find clues about which quadrant to draw a reference triangle in. So what I know is, based on this, secant is related to cosine, and secant is positive, therefore cosine is positive. So I've got a positive cosine, and what I know from this is that I've got a tangent that's negative. So based on that information, I should be able to figure out what the quadrant is. So your first order of business is to come up with two statements about sine, cosine, or tangent, and whether they are positive or negative. And with those two things combined, you should be able to figure out what quadrant you're in. Don't forget about your, they're all related to the x and y coordinates, but this little thing is helpful for some people. Have any of you been using the all students take calculus thing to help you with positives and negatives? So I'm looking for where tangent's negative. Well, tangent's, this tells you where things are positive. They're all positive here. Sine is positive here. Tangent's positive here. Cosine's positive here. So I think I want the third quadrant because I want cosine to be positive and tangent not to be positive. And cosine is the only one that's positive in that quadrant. So we're in quadrant 3. And then I'm going to put that 6 and that 5 onto my triangle based on the reference triangle. If secant is 6 over 5, that's hypotenuse over adjacent. So 6 and 5. And then I need to find my missing side. So a little Pythagorean theorem work. I did not give you much room to do this problem. I'm sorry about that. 5 squared plus x squared equals 6 squared. Let's see, 36 minus 25 is 11. So x is root 11. Is that right? 5 squared plus 11 is 36, yes. Okay. So far, so good. And then on the actual test, I'm not going to ask you to find all 6 of them. I'll only ask you to find 2 more. So let's just practice doing a couple of these. So based on that, then we should be able to come up with answers for, let's do sine theta and cotangent theta. And I will expect these to be rationalized. Please don't forget to think about signs on these. Sine and cotangent in this quadrant are both the same sign, aren't they? Aren't they both negative? Sine is negative in this quadrant, yes? So my answer is going to be negative. Cotangent is going to be negative. Every year I get somebody who will do this entire test and they will give me only positive answers. So forget that sometimes these things can be negative. So train yourself to think about whether your answer is positive or negative before you start looking at the numbers so you don't forget to do that. All right, sine is opposite over hypotenuse, so that'd be root 11 over 6. Cotangent is adjacent over opposite, which is 5 over root 11, and we'll have to fix that. So negative 5 root 11 over 11. So there's kind of 3 phases to this. Figure out what quadrant you're in and draw your reference triangle, find your missing side, and then don't forget about your positives and negatives when you go to do the answers. What else, guys? What else? Anything else from the review? Okay, then we're going to switch gears and we're going to just do some guided practice today. You're going to still have time to work today. I have the test in front of me right here, and I've gone through and I've just sort of created some alternate versions of each of the problems. So I'm going to feed these to you in the order that you're going to see them on the test. So I'm not giving you a practice test, but I'm essentially giving you a practice test. Okay, so you'll know kind of how the test is formatted and what to expect. So here we go. You'll just do these in your own notes. We'll practice together. I'm going to give you a little bit of time to start it on your own, and then I will go over each of them. So number one is all about unit conversion. We actually do not have any true-false on this test. Yay! You guys like that, or is that are you true-false enjoyers? They kind of get tricky sometimes. So, all right. So I'm going to give you. This is going to be convert to radians. So these are all conversions. And there's three parts to this. The first one is going to ask you to convert to radians. And it's 105 degrees. I'll just write these up here and let you guys copy them down. All right, I'll give you a minute or so to work on those. Let me know if you have questions, and then we'll go over and check answers. I'm not going to require work on these on the test, but it's probably a good idea. Just in case you make a mistake, you could earn some partial credit for showing work. So 105 degrees times pi over 180. And I just need to simplify 105 over 180, and I'm going to let the calculator do it for me. Seven over 12. So don't forget about your math frac for these. I do not want you guys spending a bunch of time trying to reduce things by hand, and you can make small mistakes with that. Use your resources. 7 pi over 12 for the first one. 11 pi over 15. So I want to multiply, that's radians, so I want radians down here, degrees up here, so 180 and pi's cancel. 11 times 180 over 15. 132 degrees. Here I'm just going to type in 109 plus 42 over 60 plus 18 over 3600. $109.705 will be our final answer there. Questions on those first three? All right, number two, this will also be on the first page. It asks you to find an acute, and acute is underlined, angle theta, and some other things, but it also says you must show a reference triangle. There's two parts to this. So oh, look at those. Not rationalized. Tisk, tisk, tisk. And then the way it'll be formatted on the test, down at the bottom, it'll say theta equals blank degrees and theta equals blank radians. So I want your answer in both radians and degrees. That acute is underlined because why is that important? What does that tell us about our reference triangle? What is an acute angle? Between 0 and 90. So where's our reference triangle going to be for both of these problems? It's got to be in quadrant 1. If it's an acute angle, it's got to be in quadrant 1. Acute angles are angles between 0 and 90. So and hopefully, because you've used them 1,000 times by now, you're recognizing a couple special right triangles. One's a 45, 45, 90, and one's a 30, 60, 90. Questions on that one? All right, let's keep going. This will be at the very bottom of the first page. We're still on the bottom of the first page, and this will be a pretty simple problem. It's going to say in which quadrant, is the angle. So there's 4 of these. So you just have to tell me what quadrant the angle's in. On the actual tests, it will say quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and you just have to circle it. No works required here. I'm hopeful that we're getting comfortable enough with radians that we don't have to convert those two to degrees in order to do this problem, but if you still do, then you'll need to do that work in the margins. 362. 180, 70 will be in quadrant 1. Like there, so this would be quadrant 2. Huh. I got one in each quadrant. Don't expect that you're going to use all 4 quadrants. That happened for these ones accidentally. But you could see the same quadrant appear more than once. Or wait, no, I didn't get quadrant 4. Never mind. Oh well. All right, any questions on that? If you've got some time to just be familiar with where your angles are in radians, be extreme. Like I said, I spent some time over the weekend looking over what we're doing in the next unit, and knowing your unit circle in radians, knowing where 5 pi over 4 is on the unit circle is going to be extremely beneficial to you in the next unit. All right, number 4. So now this is on page 2. Number 4 is all about coterminal angles. So I'm going to give you an angle, and the instructions are going to say circle the coterminal angles. So there'll be a list of angles, and you just have to go through and figure out which ones are coterminal. So let me give you my list here for 225. So not all of these are coterminal angles, but some of them are. I ran out of room. So 225 is what you're comparing it to. And then there'll be one in radians also. There's a little trick you can do on your calculator to make this problem very, very efficient. I think you guys all know what to do, right? You're just going to take the angle that I give you and add and subtract what? 360. Do you remember the little trick to make this easier? Type in 225, hit enter, and then type plus 360, and then you can just keep hitting enter over and over and over again, and it will just continue adding 360 each time. Do that a few times and circle the ones that match. And then go back and do it again. Oh, you're going to have to type in the 225 again, but then do minus 360. That way you don't have to keep typing minus 360. You can just hit enter a few times and circle the ones that match. When you do this in radians, I'll show you how to do this in radians. You're just going to type in the angle without the pi, and hit enter. So type in 2 divided by 3. We're leaving the pi out. And then do plus 2 math frac. So I'm adding 2 pi, right? So I'm leaving out the pi. When I put stuff in a calculator, I leave out the pi. So 2/3 and then plus 2 math frac. And that'll keep adding 2. So 8 pi over 3, 14 pi over 3, 20 pi over 3, 26 pi over 3. 2 pi over 3. So which ones match here? Not that. This one does. Not that. Not that. All right, so that's number 4. Number 5, also on page 2, we're going to evaluate. There are 4 parts to this, and a x and y axis is provided for you to create a reference triangle. You have to do your reference triangle to get credit for these. Some of you who are working ahead on your memorization might know some of these already. Okay, those of you who do your memorization quizzes, by the end of next chapter, you're going to be able to do these without doing a reference triangle. You'll just be able to look at it and spit out an answer. But for this one, you will need to show me a reference triangle. So I'm looking at the wrong thing. Here we go. Okay. I'm sorry. The XY axis is not provided to you. I was looking at the review. So there's space for it though, and the instructions say you must draw and label a reference triangle on the appropriate quadrant to earn credit. So not hiding anything from you. So we're going to do 4 of them. Cosine 225 degrees. The cosecant of pi over 3. The secant of 7 pi over 6. And the cotangent of negative 3 pi over 2. Aren't you guys glad you memorized your degrees to radians and radians to degrees? Sure does make this a lot easier. So I'll work through these silently up here. You guys can peek up here if you need a hint. The instructions do say to rationalize and simplify. I don't like this last one because it conflicts with the instructions, so I'm going to change it. Sorry if you've already done it. We should be able to handle quadrantals, but the one that I had, the angle's not in a quadrant, and the instructions say to draw a reference triangle, and can't draw a reference triangle for that one. So let me switch this up. Cotangent of negative. Let's see, let's do a 45, 45, 90, negative 7 pi over 4. Let's see. That's 315. Should be here. Please ask a question if you're unsure how to do these. I'll tell you the biggest skill that you need to have in order to pull these off is when you see 225 degrees or 7 pi over 6 is being able to quickly figure out where on the unit circle that is, being able to envision that. And at this point, you've done dozens of problems like this where you had to do this. If you wanted a way to practice that, you could create yourself some flashcards with some different angles. Pull out your unit circle sheet. I've mislocated mine. You guys had that unit circle sheet, that activity that we did at the beginning of the last unit that has all your angles all the way around in degrees and radians. Pull that out, make some flashcards for yourself, and on one side you could have 7 pi over 4, and on the flip side you could have, kind of where it is on your unit circle. But that's kind of the big thing. If you're struggling to do that, if you have to go through and convert, especially if you have to longhand convert pi over 3 into 60 degrees and then walk yourself around the unit circle, this is going to take you a lot longer than somebody who knows where these things are on the unit circle. So once you have that, then it's just a matter of recognizing whether your reference angle is a 30 degree, 60 degree, or 45 degree. And then don't forget your positives and negatives. When you get to this on the test, I will go through and just put a plus minus right next to the very first problem just to remind yourself to go back and check positives and negatives. Okay, number 6 is at the bottom of the second page, and this will be the last one that we do today, and then Wednesday I'll go through the second half of the test with you kind of the same way. But I want to give you guys some time to work and ask questions today. I don't want to take all your time. So this is kind of like the one that we went over from the practice, or from the review. If cosine theta is equal to negative 3 over 7, and sine of theta is greater than 0, it's going to ask you to find, and let's go ahead and find sine theta and cotangent theta. So your first order of business is to figure out, based on the information given, some information about sine and cosine, and is each of those positive or negative based on what you got. Once you know whether sine is positive or negative and cosine is positive or negative, you can figure out what quadrant we're going to be in. All right. The rest of your time is yours to do as you see fit. I would prioritize that review if you haven't finished that yet. If you haven't had a chance to check your answers, they are in Canvas. I haven't put up the new Canvas for this week yet, but if you look at last week's, there is a link to the review answers as the solutions on it too. I've also got a paper copy still sitting on the counter over there, so help yourself to that if you like. Would you like to know what the last 2 pages of the test look like, just to kind of get an idea, and then we'll go over some sample problems? Yes? No? Okay. Well, if you don't, then don't listen. I'm going to tell you anyways. So on page 3, you're going to have a second problem that's just like this. So number 7 is just going to be the same as this. And then number 8, I'm going to give you a graph of a sinusoidal. And you will be asked to find the period amplitude and write the equation of it. And then number 9, I'm going to give you the equation of a sinusoidal, and you have to graph it. Number 10, I'm going to give you a sinusoidal, and you have to tell me the period, the domain, and the range, and then also describe the transformations that you would do to create this function. So this is going back to some chapter 2 or chapter 1 stuff. So you're going to say things like reflect over the x-axis, vertical stretch by a factor of 5, shift down 3, horizontal compression by a factor of 1/2, shift right by 5. So that all should be second nature to you now. We haven't done a lot of practice with that. We'll practice one of those on Wednesday. The back page, number 11, you've got an inverse well, on this version it's an inverse cosine. The other one, it's an inverse sine. You'll have an inverse trig function. Could be inverse tangent. And then you'll have another one where it's like an inverse and then a regular one on the inside. So like 2 of them that are nested inside of each other. Number 12 is a word problem that's going to either involve like tides. So it'll be something, remember the Bob, the alien, the problem where Bob got off the spaceship and like the low temperature happened 2 hours later and it was this, and then the high temperature happened 8 hours after that and it was this. It's going to be something like that. But it may not be temperatures, it may be like the depth of the water, rising and falling because of the tides, but it'll be very similar to that. And then number 13 is a old school SOHCAHTOA right triangle word problem. Think about like a ladder leaning up against a wall or a person flying a kite. This problem was actually on the geometry test that I gave last week. So, and they did awesome on it. So if they can do it, this will be like the easy one on the test. Okay. We'll go over examples of each of those on Wednesday. You guys let me know today with the remaining time what I can do to support you.